Hello everyone, welcome to my channel Dr. Tapati's presentation. Myself Dr. Tapati Vanjade. I have started a lecture series on enzyme. This is unit 6. In this unit, I am going to discuss about enzyme kinetics. This is the first video on enzyme kinetics. In this video, you are going to know about what is enzyme kinetics, why do we study enzyme kinetics, order of the reaction. In order of the reaction, we will know what is the order of the reaction, expression of the rate of the reaction, and types of the order of the reaction. First of all, know what is enzyme kinetics. The study of the rates of enzyme catalyzed biochemical reactions is called enzyme kinetics. Study of the rates of enzyme catalyzed reactions is called enzyme kinetics. It refers to the relationship between the rate of a chemical reaction and the concentration of the substrates participating in the process. In enzyme kinetics, the rate of the reaction is measured and effects of change of the reaction conditions are also investigated. So main purpose of the enzyme kinetics, study of the enzyme kinetics is rate of the reaction, measurement of rate of the reaction, and another purpose is to study the effects of the change of the reaction conditions. Now, what is rate of the reaction? Rate of the reaction or reaction rate is velocity of the reaction to convert the reactants into its product. Why do we study enzyme kinetics? Or what is the purpose of studying enzyme kinetics? The study of enzyme kinetics is important for two basic reasons. First of all, it helps explain how enzymes work, or we can understand catalytic mechanism of that enzyme. Secondly, it helps predict how enzymes behave in living organisms. We can understand its role in the metabolism, how its activity is controlled, and how a drug or an inhibitor or an activator might affect the rate of the reaction. These are the two purposes of studying enzyme kinetics. Before going to details of enzyme kinetics, you should know about order of chemical reaction. What is the order of a reaction? Chemical reaction shows different reaction rates which depends on different ways on the concentration of reactants. This relationship between reaction rate and concentration of reactant is described as the order of the reaction. Order of the reaction is the number of reacting species. It is the number of reacting species whose concentration determines the rate at which the reaction occurs. It can be whole number. It can be whole number or a fraction or 0. It can be positive or negative. Expression of the rate of the reaction. In order to determine the reaction order, the power law form of the rate equation is generally used. Power law form. According to power law form, rate of the reaction is equal to minus ds by dt, that is equal to k into s power of x into s prime power of y, where k is equal to rate constant, s and s prime are the concentrations of two reactants. The exponents of the concentrations of the reactants, those are x and y, are referred to as partial orders of the reaction. The sum of all the partial orders of the reaction yields the overall order of the reaction, that is x plus y. X plus y is the overall order of the reaction. That means total of the sum of the exponents of concentrations. In this case, x and y both are exponents of two reactants. So overall order of the reaction will be x plus y. Order of a reaction may be 0 order, first order, second order, third order, or more than 3. In case of 0 order, breakdown rate is independent of concentration of the reactants. In that case, it is expressed as V is equal to minus ds by dt is equal to K into substrate concentration power of 0. As substrate concentration power of substrate concentration is 0, so we can write it as V is equal to K. That means rate of the reaction is not dependent on the concentration of the substrate. It is only the value of the rate constant. Here K is equal to rate constant. In case of first order reaction rate is determined by the concentration of the one reactant. In that case, V is equal to minus ds by dt is equal to K into substrate concentration power of only 1. As the power of substrate concentration is 1, therefore it is first order reaction. In case of second order reaction rate is determined by concentrations of two reacting species. In that case, V is equal to minus ds by dt is equal to K into S power of 2. Here power of substrate concentration is 2, therefore it is second order reaction. In case of third order and higher order of reactions, reaction rate is determined by concentrations of 3 or more than 3 reacting species. In that case, V is equal to K into S to the power 3 or above. If it is third order reaction, in that case power of substrate is 3 and if it is the higher order reaction, then power of substrate will be above 3. The most important orders of the reaction are 0 order, first order and second order reactions. They are very common. The decomposition of many drugs can occur simultaneously by 2 or more pathways. In that case, it complicates the determination of rate constant. So, determination of rate constant of decomposition of drugs is difficult. In my next video, I will discuss about zero order reaction. Thank you very much for watching this video. Kindly like, share and subscribe this channel. For further notification, don't forget to press the bell icon.